This is WellSeeker Pro training, and this video will cover the WellSeeker Pro database tree. So the database tree is this area here, and the database tree will appear in this section here. What I'm going to do is I'm just going to create an instant database tree structure, just so you can see what it looks like. So if I right-click on my WellSeeker database tree, I can then go to Insert Instance Survey. Close that for now. Okay, so what this effectively does is it creates an instant structure that we can see here, and the WellSeeker database tree is built in a series of top to lower level sequences. So we've got the operator here. Under an operator you can have multiple fields, in this case we've just got one. Under a field or county you can have multiple facilities or pads. Under a pad you can have multiple different wells or wellhead locations. And then under a specific wellhead you can have one actual well or multiple actual wells with multiple surveys associated with them. Under a well you can also, as well as actual wells with surveys, you can have plans. Okay, so that is the general structure of a WellSeeker database. Operator or customer, field or county, facility or pad, well or wellhead, and then under the wellhead you have actual wells that have physically been drilled with surveys underneath that level, and also under the wellhead plans. So you can have multiple plans, multiple actual wells under the same wellhead. So now that we're aware of how WellSeeker structures its data for well bores and the associated structures around that, we can now go ahead and look at the details and the properties within those different levels. So we'll start at the top and work our way down. If I select on the level of the database tree that I'm interested in, and I can either open the properties by going to the toolbar here with that level selected, or I can right click on the level I've got selected, which opens up the right click menu, and go to properties. Okay, so most things you find in the right click menu you can also find on a toolbar somewhere. Okay, so I'm going to open properties. So I've opened the properties for my operator here called new operator. Now I'm going to change the name of my operator to client example. Okay, you would input any contact or address details you've got the client, and these are purely for reporting purposes. On the left here you've got the ability to add logos. So the logos can either be in bitmap, PNG or JPEG format currently, and you select that image and pull it in. So that logo will then appear on any reports that you choose to display that on when they're printed. You can also choose a secondary logo. This would probably be your own company's logo. That can also be added to reports, so it's displayed along with the client's logo. Also within the operator properties you've got the anti-collision settings. The anti-collision settings, you would input the anti-collision policy that the client has, and if they don't have an anti-collision policy and you're using your own, you would input your anti-collision policy settings here. Okay, so we can just run through them very quickly. We've got the scan method of the anti-collision scan, the error surface, the warning type, the error output at sigma, so effectively the 2 sigma is approximately 95% probability, whether to include casing in your anti-collision calculations or not, and if it is selected, whether you add or subtract the casing rule, whether errors are calculated from surface or mudline in the case of an offshore well, and the travelling cylinder plot safety factor. So on the right here you've got the warning levels. Okay, so these are associated with separation factor and how they will display on your separation factor plots and within our anti-collision dialogues. We've also got here a set password section. So for each of these properties dialogues within your database tree, we have the ability to lock those levels. So if you're in the office and you set up the job in advance before sending it out to the field, you can lock certain properties windows so that people without the password cannot access it. So for example, to set that up, you would hit locked. Now without a password, anyone can just unlock this dialog. If you wanted to make it so that people couldn't unlock and then edit the inputs within a dialog, you could set up a password and lock it. So I'm going to set up a password, and it's just going to be called password. I would advise something a little bit more stringent than this if you do it yourself. Okay, hit apply, and now if I try and lock the dialog, it's going to ask me for the relevant password. If I don't have it, it won't lock it for me. If I do, however, have it, password, hit OK, it's now locked this particular properties dialog, and so the user cannot edit critical settings in there. So this is really a tool for the office admins then sending this database out to a location where they don't want the end user to be able to edit some of the dialog inputs. Okay, for the rest of these purposes, I'm just going to unlock them and get rid of the password. But that's showing you how the password and locking functionality works within the WellSeeker tree dialogues. Okay, if you want to reset your password back to no password, you just put in old password as whatever you had, and then leave new password and confirm new password blank. If you hit apply, then you get back to the state where you didn't need a password to lock and unlock. Okay, whenever you make changes to any field in a dialog, hit apply. If you don't hit apply and just hit close, those changes will not be saved. So hit apply, hit close. You can now see in the database tree my client name that I input has now been updated to client example as I input it. Okay, next we're going to go from operator down to field or county, depending on where you are in the world. So again, to get to the properties, I either left click on my new field and go to the properties, or right click and go to properties from the right click menu. The field properties are where we can input the name of the field, so I'm just going to call this example field/county. Below that is where you can select the coordinates reference system. So there's already a list of coordinates reference systems that comes as standard within WellSeeker, and you can see the details for this currently selected coordinates reference system by selecting mapping grid. Okay, you can take a coordinates reference system and export it, import an exported coordinates reference system. You can delete a coordinates reference system, edit an existing one in the list, save it to a text file, or you can add a coordinates reference system. And there's a separate guide to creating a coordinates reference system within Innova's standard documentation included within the install. Okay, so that is your coordinates reference system. If I hit N, it will shortcut any coordinates reference system starting with N, and then I'll go ahead and select. Okay, once you've selected your coordinates reference system, that will be associated with all the paths and wells below this level. Then you can move on to selecting your azimuth north reference, whether that be grid or true. And again, this azimuth north reference will be the same for every well under this level. The local coordinate system can either be well-centered or facility-centered, and by local coordinate system we mean your surface tile line. So if it's well-centered, your MD, INC, ASI and north, south, east, west will all be 0. If it were facility centered, your MD, INC, ASI would all be 0, and then your north, south, east, west coordinates would be not 0, i.e. centered on a facility point somewhere, or pad center. So you can select one of those two. If the coordinates reference system that you've selected has a scale factor within its properties, you can select whether to apply the scale factor or not. This option here is show field reference point on report, and effectively what this does is it takes these coordinates here and it decides whether you are going to display that on any of your survey reports or anti-collision reports or not. In the case of in the US, where it's a county, it's not really relevant to have field reference coordinates. In other parts of the world where you do have a physical field boundary, it is relevant to include those coordinates on reports. So it gives the user the option to do that here. We also have the show map option. So what that does is it takes your latitude and longitude, grid easting and grid northing coordinates, and it finds that physical location on the Earth using Google Maps. So something to bear in mind is we can zoom in by holding the control key and using the mouse scroll wheel, and also switch to satellite mode. So something to bear in mind here is that this pin is very good and accurate as long as your coordinates reference system is referenced to the same thing that Google Maps is, i.e. WGS84. If you aren't using WGS84, so in this case we've got NAD27, use the Clark 1866 ellipsoid, then your pinpoint on the map won't match exactly where it is in the real world. And again, that is because Google Maps uses WGS84 and NAD 27 and 84 use a different ellipsoid. Okay, we can close the map by hitting the same button again. And then if we move on to the field reference point. So the field reference point is the center point of your field or whatever reference they have for that particular field. So you can input that either as latitude, longitude coordinates, and whether it be north or south, and then east and west for your longitude, or you can select the input here to be grid eastings and northings. If I have the option, I will always choose grid eastings and northings, purely on the basis that the decimal place of either a foot or a meter, depending on your coordinates reference system, is more accurate than a decimal point of a second when it comes to the degrees, minutes, seconds of a latitude or longitude. So if possible, input in grid eastings and grid northings because it's more accurate. Based upon your latitude and longitude coordinates and your coordinates reference system, we will also generate a grid convergence from that information. And the next thing in our properties is the system vertical datum. So this is the vertical depth reference, or TVD reference, that will be used to compare one well to another. So this is not to be confused with your measured depth reference for a single well. This is something that is permanent and used to reference multiple wells. The standard one that is used most locations worldwide is mean sea level. Okay, but you can also select ground level, mudline, or user defined. There are areas in the world that use specifics, like a lake level, or in parts of the Netherlands they'll use the mean level of a canal. So you do have options here to set as your system vertical datum. So if you follow this training, you'll get used to my terrible drawings in paint. So effectively what I've got here is a very, very rudimentary rig with its RKB/rotary table elevation. I've got a depiction of ground level, which obviously changes depending where you are. And then we've got an example here of what a system datum is, i.e. mean sea level. So you'll see here that the RKB, either local depth references are related to the rig, and that will change in elevation based upon where that rig is, where the ground level is, which rig in terms of the air gap is. But the system datum, the one that we refer to in the field property levels, is the one that all of the wells are measured against in terms of TVD sub C. Okay, so in this case, mean sea level would be the example. Okay, so that covers the field properties and all of the individual parts within that. Once again, if you've made any changes, hit apply before you hit close, otherwise those set changes will not be saved. So we've looked at the operator, the field. Now we're going to go on to the facility or pad level. Again, I'm going to select, this time I'll use the toolbar to open it. Go to properties. Okay, and I'm going to change that to example. Then we'll go to example facility / pad. Okay, so facility, pad, they're exactly the same thing. Okay, we can see there's a few things that are greyed out here. Our azimuth north reference, our local coordinate system, and our mapping grid. And that's because all of those have been selected at field level already. And everything below field level has to stick to the same coordinates reference system, the same north reference, and the same local coordinate system. If you do have wells that for whatever reason are in the same under the same operator in the same field or county, but your client has decided they must be referenced to a different north than some of the other wells, or have a different centre or a different mapping grid, then you would have to create a new field under the same operator and just make the relevant changes. Okay, so greyed out options have already been selected at field level. We then have a lease hard lines on and off button here. What this effectively does is if there's any lease lines that have been created and associated with this facility pad level, if you select on, any wells on that facility will automatically, when you open up a plot, display those lease lines and hard lines. If you select off, it won't display them. If you go to show map, the same functionality that we had at field level. Templates. This is effectively for a planning stage. You can set up the template for slots on a pad. So if you've got an offshore platform, for example, or a slot template that is predefined distances between wellheads, you can set up a slot template here, so that when you do come to inputting the individual wells, you've already got the wellhead location in place. The facility reference point, so this is the reference point for your pad. Again, much like at field level, you can choose to input it between latitude and longitude or grid eastings and northings. Again, I would always say input grid eastings and northings if possible, due to the fact that it's more accurate to the same number of decimal places. We have a new option available here that wasn't visible at field level, and that's facility location uncertainty in both horizontal and vertical vectors. What this pertains to is when you have a company that is surveying your wellhead or your facility pad location. So they're the ones that give you the physical coordinates of where your facility is. This is the degree of uncertainty that they have on that surface site survey. So if they're happy with the exact location of where they are, then you can leave these as 0. If there is any discrepancy within their survey measurements, then you can impact that here. This will directly affect the ellipse of uncertainty measurements within your anti-collision scans based upon any uncertainty at the start point. Okay, again, we've made changes, so I hit apply and close. So we've covered operator, field, and facility. On a facility or a pad, you can have multiple wellheads, and that's what this next level is, the well level. So left click and go to properties, and I'm going to call this example well/wellhead. Okay, so much like at the facility level, we've got a location uncertainty. Again, this is for the site survey location of your wellhead. If there's any uncertainty in terms of where your wellhead is, that can be input here, and it directly influences the ellipse of uncertainty calculation and how that interacts with your anti-collision scanners. Wellhead location. So this is where, if we selected in the facility, if we created a slot template, then we'd be able to select any of the slots we'd already created. As we haven't, this selection is greyed out. We can have our wellhead location as an offset from facility. We can put it in as map grid northings and eastings, which is probably the simplest way, or as geographic lat longs. I would normally use the map grid northings and eastings again because it's more accurate than your geographic lat longs. Again, your grid convergence is automatically calculated and the scale factor is shown. Anything that's greyed out is generally already been selected at a higher level. Okay, and the other part for a wellhead properties section is this depth reference table we've got here. So by default, there is a depth reference of 0 input. If we wanted, say, we have a location and a rig has arrived on location, and the distance from our depth reference, which we're going to be measured depth reference from, is going to be the rotary table elevation. Okay, so I'll put in RTE for my rotary table elevation, and whatever distance it is from my rotary table to my permanent depth datum that we selected at field level, which in our case was mean sea level, is what the value we put in here. So elevation above system would be rotary table to mean sea level. I'm just going to input that as 435. Okay, you can input the name of the rig here, like, just as a reference, and then check the default box. And what the default box does, it's not critical that you do this, but any actual wells that we create below this wellhead, when we create them, will automatically be given this depth reference. So you can change it at a later date, but it will have this one when it's first created. Okay, with row 2 selected, we can now see that the software assumes that our datum to system, i.e. mean sea level, is 435, because we even put it here. But it also assumes that our air gap to ground level, i.e. our rotary table to ground level, is 435. And that is because we haven't input our ground elevation to mean sea level yet. What we need to input here is our ground level to mean sea level. So in this case, it will be 400. And you'll see it automatically calculates our air gap to ground level. So once we're happy with our depth reference information here, we can hit apply and close. Something that is important to note here is within depth reference, we can have multiple depth references input. And that is because for a wellhead, you might not necessarily always have the same rig on location drilling one or multiple different wells. So in the example where you've got one well, you could have one rig, this example rig, with an air gap of 35 feet, drilling the top hole sections, batch drilling on a pad. And then you come in for the intermediate and further sections with a different rig, with a different rotary table elevation. So we could simulate that here. And we're just going to call it 445 example rig 2. Okay, so our ground level to mean sea level hasn't changed at the wellhead, so that's still going to be 400. And now it's calculated that our air gap, based upon this information, is 45 feet. So we've got effectively a taller rig with a bigger gap between ground level and the rotary table. So this will become apparent when we go down to the actual well level and we're able to select different depth references. But this is where you create your depth references to then become selectable at our actual well level later. Okay, so client, field, facility or pad, and well or wellhead level. Next, under a wellhead, things that you can have are an actual well, which has surveys used to build it, or a plan. We're going to start off with a plan, because that is effectively what you would start with before you create an actual well in the ground. So I'm going to left click on New Plan, and I'm going to open up the properties. Let's call example plan. Right, we've got the description, which again is just for reporting purposes. It doesn't need to be input. And then we've got this box here, set as principal plan. So the principal plan is your definitive plan. You can have as many plans as you like under a wellhead, but only one of them at any given time will be the principal plan, i.e. the plan that we're comparing our surveys to as we're drilling a well, and the one we're trying to stick to. So in this case, we've only got one plan, so I'm going to go ahead and make it the principal plan. I'll just hit apply now. You'll see there is now a little red box around my plan that wasn't there before. That indicates that it is the principal plan under my wellhead level. So that is the one that we'd be using going forward. That's what it does. So any up, down, left, right distances from plan are referenced to the principal plan alone. Tolerance circles. So if you're viewing a plan view plot of your plan, tolerance circles will effectively give, they'll draw a circle at surface of a particular radius. So if you're drilling a perfectly vertical well and you need some form of horizontal displacement marker that is easy to view on your plan view plot, this is where you'd input them. These can then be displayed later on charts. Vertical section. So this effectively is where you can input your vertical section origins. Okay, so well, facility, or user defined. You can also uncheck this box and use bottom hole location. So by default, whatever your plan bottom hole location is, it will choose a vertical section azimuth that corresponds to your plan. If you uncheck it, you can manually input a vertical section azimuth, which effectively is the side slice angle that you view your section view plot on. Okay, next section is our depth reference, and it's currently selected as default. I'm going to want to select from this drop-down menu. And remember, this is what we created at our wellhead properties. We've already created these depth references. If we hadn't created them, the only one that would be available would be default. So I'm going to select rotary table elevation. If we change our depth reference, we get a warning. Okay, datum is currently in use by one or more actual wells, which is this one. Do you wish to change the TVDs to reflect this or preserve the original TVDs? This action can seriously corrupt your designs. So since we don't actually have any information in our plan, this isn't something to worry about. But if you did have a plan already in existence, this is quite a critical point. So if you preserve TVDs, but you change your depth reference, effectively your TVDs would remain the same, which means you actually would be referencing a different TVD subsea. If you select change TVDs, your TVD subseas will remain the same, but your TVDs related to your depth reference will change. So, as I say, because we don't have any information at this stage, it doesn't matter which we select. But if you actually had information, this is important. Okay, once we've selected our depth reference, move on to the magnetic section. So, within WellSeeker Pro, there are 6 pre-installed at date of release magnetic models. So 2 of which are the most up-to-date for their version. You've got IGRF 13 and WMM 2020, and these are open source, free magnetic models. They're updated every 5 years. So you can select date and the model, and once you've selected the date and the model, it will automatically generate the magnetics information for this plan location, i.e. where your wellhead is. Okay, the date matters because your magnetics information will change dependent upon date. Check the active line. So you can have multiple rows of information here, but the one that the software uses is going to be the one selected as active. Okay. You can also select user defined and then input values as required. So again, I'll just put user defined date. Okay, so if you have a model that is not integrated within Wellseeker Pro, but you have information that you want to use, you can select user defined, input the declination, dip and total field strength values, and hit active, and that will be the row used. Magnetics data is important because the magnetics data is utilized in the calculation of your ellipses of uncertainty and affects your separation factor anti-collision scan results. Sidetrack details. Okay, so this is where if you're creating a sidetrack, you check sidetrack and select the wellbore you're sidetracking from and the sidetrack depth. You would then hit create sidetrack, and that would carry out the tie-on of your plan from that sidetrack point. Okay, next we've got export geomag data. We can either export the geomag line that we've currently got selected to PDF or Excel format. If you hit export, it will generate a report with this information in. The next section is our survey program. Within the plan properties, until you've actually got data within the plan, this will remain empty. But once you've created your plan, you would come in here and select your instrument performance model. And again, there's a preset listing of instrument performance models within Wellseeker upon install, and you can select from these. So the instrument performance model is important because, again, much like the magnetics, it affects the ellipse of uncertainty that is used in your anti-collision separation factor scan results. We've then got the tie-on section, and so this is where your plan will tie on from. In this case, you can choose from surface, user defined, or from a survey or plan on another well under this wellhead. Okay, this little reminder that all depths are relative to the rotary table elevation that we've got here. Other options are chart color. So by default within Wellseeker, plans are displayed on charts as blue and actual wells are displayed red. But if you want this particular plan to show up in a particular color on all of the plots that you show it on, you can check force color and select any color from a large range for it to be displayed in. So if you want one to stand out consistently, you can set forced colors for those wells. Okay, the other one is survey tools. This is just a shortcut to another dialog we've got within Wellseeker Pro, and it just allows you to look at the instrument performance models in greater detail. But bear in mind, this does not select your IPM used in your survey program. It's just to look up the reference information within a particular IPM. Okay, once you're happy with your plan properties, you hit apply. Okay, we can actually open up a plan here. I'm just going to double left click on example plan, and this opens up our editable plan dialog. This is not to be confused with the level below, our planned wellbore. If you double left click on that, it's not editable, there are no tools, and you can't actually do very much with this. So close that out. If you're ever accessing a plan, you want to go to the plan level, the one that doesn't have a W next to it. Okay, this is the editable one that comes with planning tools. So you can input a plan either by just typing MD Inc ASCII, or you can select various planning tools, select the row, select the planning tool, select what variables you want to plan to, and then hit calculate. Okay, there is a separate training course that involves planning tools and well planning that will cover this in more detail, but this is just so you're aware how to open it, where it is. Once you've made your changes, hit save, and that will save what you've done here to the survey program. Survey program again is located in your plan properties. It's this section here. But this is actually where our survey program is set up and where our list of uncertainty will be created from. So we need to select an instrument performance model to be associated with our plan over this depth interval. So I'm just going to select bog standard MWD. And now, when I hit apply, from 0 to 400 feet, the instrument performance model MWD is associated with our plan. Okay, so that's very quickly touching on opening up a plan and the plan properties. The other levels of the database tree that we haven't covered are the new actual well and the survey that comes under an actual well. So we're going to go ahead and look at those now. So I'm left clicking on my new actual well and going to properties. Okay, so again, we can change the name here. I'm going to call it new example actual well. Much like on the plan, we've got inner and outer tolerance circle inputs. We've got a vertical section options. We've got our depth reference options. We've got our magnetics data options. And we have a survey program, side tracking information, geomag data sheet, forced color. Okay, so the only thing that's different is this build rate to land section here. This section is going to be covered on a different training video. Okay, so there isn't much to do very early on with an actual Wellbore properties other than rename it, make sure your vertical section azimuth and origins are set up correctly, select the correct depth reference, input your magnetics correctly, and then hit apply. Okay, once you've got that, you would insert a new survey or edit an existing one. So much like all the other levels, you go down and left click. Right click and go to properties or the main toolbar. Okay, and I'm going to call this, because it's surface surveys, and MWD. So it's always useful to note what type of tool took the surveys, because you can have multiple surveys over the same depth interval just measured by different instruments. So for example, you might have a surface hole measured by single shot, then by MWD, and then by gyro. You select next the tie-on coordinates for your survey. Select from surface, user defined, or from a survey that is located under the wellhead. I'm going to select from surface, and again I'm going to select my instrument performance model as bog standard MWD. Now, much like for the plan, to open it, the surveys, you double left click on the surveys. Again, you've got another level in the database tree called actual Wellbore. Much like the planned Wellbore, it has a W next to it. If you double left click on that, it's a non-editable definitive listing. Okay, so the planned Wellbore and the actual Wellbore with the W's next to them, those cannot be edited. The ones you want to add surveys to are your surveys and plans. Okay, so again with surveys, you can either manually type these in, or you can copy and paste from an Excel document. So just make sure they're in the same column order, MD, Inc, ASI, and then you can copy in literally hundreds in one go. So now that we've saved this, we can go back to our actual Wellbore properties. You can see the survey program is updated, and we'd already selected the IPM in the survey properties be associated here. Okay, just very briefly to show you how the survey program works here, we're going to add let's come up with this new survey, and we're going to go ahead and call it Intermediate Surveys NWD. And now, instead of tying on from surface, we're going to tie onto our previous in-depth of our survey. So we're going to select from survey, select the survey it's tied on from, and it's going to tie on to the measured depth. We're also going to select our IPM and hit apply. Now we open up our intermediate surveys, and then we can carry on with a different survey interval. Hit save. Do you wish to add this to the survey program? Yes. So now when we go back to our actual well properties and look at the survey program, you can see we've broken down our survey program into two separate sections: surface surveys and intermediate surveys. Now, why I keep drumming on about the survey program is it's where our definitive survey listing comes from. If we go ahead and add in another survey and call it surface gyro, tie on from surface, and we give it a gyro north seeking IPM. We open up our gyro surveys, save it, okay, close these out. So effectively what we've got here are three surveys. The surface one's coming from 0 to 100 foot, and then the intermediate 100 to 200 foot. If we go back to our survey program, we can select which surveys we use to cover this interval 0 to 100, because we have multiple different sets of survey data for that. Okay, so we can change from surface surveys MWD to surface gyro, and you'll see here the IPM changes based upon what we had in our surface gyro survey properties. Then you hit save. Okay, so this is why the survey program is important. It lays out exactly what our definitive listing is, and you can have multiple surveys under here, some of which don't even get used in the definitive survey listing of the survey program. They're just for record purposes. Okay, so just to highlight that to you guys. Right, so that effectively covers the well seeker database tree. What I will show you is that we built this instantly to show all the levels. You can actually go ahead and create these individually. So you'd right click on well seeker database, insert new operator. At the operator level, you right click and you can insert new field. Under a field, you can right click, insert a facility or pad. Under a facility, you can right click and insert a well. And under a well, you can insert an actual well. And under an actual well, you can insert surveys. Again, under the well, you can insert planned wells. So that is how you manually create these different levels. And again, under facilities, you can have multiple wells. Under fields, you can have multiple facilities. Okay, so you see how starting with one operator, one field, you can then have one operator, multiple fields, multiple facilities under them, multiple wells under those, and then multiple actual wells and multiple plans under those. So it very quickly grows into a large database structure. An important point to note is that every single level of the well seeker database tree must be named uniquely. So for example, I cannot have one field named the same as the other, and the same applies right the way down to the actual well and the planned well levels. You cannot have a field the same name as another field, a facility the same name as another facility, a well the same name as another well, an actual well the same name as another actual well, or a plan with the same name as another plan. If, for example, I try to rename this field the same as another field, okay, it says the name already exists and it won't let me do it. The reason behind that is that WellSeeker in the background uses the unique nature of each name to identify each level of the database tree. So in the example, if we had two actual wells named 1H, even though one was under a different operator in a totally different field under a different pad, if you made changes to one of the wells, 1H, and hit save, the exact same changes would be made to the other well, 1H, in a totally separate operator pad facility, because they're both named 1H. So that is why you need to have unique naming for each level of the WellSeeker database tree to avoid corrupting your database. Okay, now that we've been through the training for this particular overview, now we've got some questions on what you've just seen. First question, what level of the database tree is the azimuth north reference set? If you don't know the answer, pause now before we give the answer. Okay, the answer is in the field properties. So we set up the azimuth north reference, we select that in the field properties, and that dictates all of the levels below that field what the azimuth north reference will be. Next question, what level of the database tree are the anti-collision settings input? Again, pause if you don't know the answer, go find out, and restart the video when you do. Okay, that can be input at the operator properties. So this is where the operator's anti-collision policy inputs are set, and this affects every single level below the operator. Next question, what level of the database tree are depth references created? Okay, pause, unless you want to find out the answer right now. At the well properties. So the following question goes on, but the well properties is where we input our depth references that can then be selected at different levels. So we can have multiple different depth references created at the well properties level. Next question, at what level of the database tree is a depth reference chosen and applied? And I'll give you a clue, there are two answers to this. Pause if you don't know the answer, find out and come back. Okay, this can be, the depth reference can be chosen and applied at the actual wellbore and at the plan properties levels. So an actual wellbore can have a depth reference, as can a plan. Next question, what level of the database tree is a coordinates reference system chosen and applied? Pause if you don't know. That is chosen and applied at the field properties level. So that's where you choose your coordinates reference system, and then any coordinates, latitude and longitude, grid northings and eastings, will be referenced to that coordinates reference system for all levels below that field. Next question, what is critical to consider when naming each level of the database tree? Pause if you don't know the answer and come back when you do. Okay, the answer is each level name must be unique due to the reasons outlined in the video. Okay, that's the end of the questions and answers. Following on from this, we will have an exercise for you to follow. So the exercise is create a new database in a suitable folder location. Select the database so that WellSeeker is accessing the database you just created. Then add the following levels and fill in each level's properties. Those properties can just be filled in with dummy data. So we have one operator, one field, one facility, and on that facility we have two wells, or wellheads. And then for each of those wells, we have one actual wellbore. And then for each actual wellbore, we have two surveys, and then input some dummy surveys for each of those. Okay, under each well, we also, as well as one actual wellbore, we have two plans. And input a makeshift plan under each. For one of the wells, tie on the second survey to the end point of the first survey. Okay, so effectively we're creating a survey program here with sequential surveys tying on one to the other. And then for one of the plans under each well, make it the principal plan. So if at any point you become stuck or you can't remember how to do any of these, refer back to the video for a refresher until you've completed the exercise. Okay, that concludes the WellSeeker Pro database tree training.